Stars are made mostly of hydrogen and helium inside their cores. The temperature and pressure are high enough for fusion reactions to take place that turn hydrogen nuclei into helium. During this transformation, a huge amount of energy is released which travels outward and eventually escapes into space as light and other forms of electromagnetic, music, radiation. Stars inside the star. The outward pressure of radiation from the core is opposed by the inward force of gravity due to the star's mass. For most of the star's life, these two forces are in balance. Over time, the amount of hydrogen in the core, the main fusion fuel, decreases. When the core hydrogen runs out, gravity gains the upper hand for a while and squeezes the core harder, raising its temperature until it's high enough for the fusion of helium into carbon to take place. Fusion. If the star's massive enough, the core fusion of elements heavier than carbon may eventually take place, producing nuclei of oxygen, neon, silicon, and sulfur. In the most massive stars, those with at least 25 times the mass of the Sun, this gradual buildup of heavier and heavier nuclei can continue as far as iron, but then it must stop. Diffuse iron takes more energy than is released from the reaction. Music. Collapse. With the outward flow of radiation stopped, gravity is suddenly unopposed. All of the outer layers of the star collapse at speeds of up to a quarter the speed of light. They then rebound off the compressed core and fly off into space as a supernova explosion. What's left, the remains of the collapsed stellar core, can take one of two forms. In the first, the protons and electrons of the old star are squeezed together so hard that they form neutrons. The whole star becomes a ball of neutrons about 20 kilometers wide, a neutron star. Black holes. If the remnant core is at least 3 times as massive as the Sun, no force in nature can prevent gravity from squeezing the core beyond the neutron star stage to become a black hole. In a fraction of a second, all the remaining mass of the star, the matter that wasn't thrown off as a supernova, is squeezed down to a single point called a singularity. Red giants. We don't need to worry about the Sun ever becoming a black hole. It'll never get past the helium burning stage. When stars like the Sun run out of fuel, their outer layers expand to become a red giant before wafting away into space as a glowing nebula. The dead core is left behind as a white dwarf similar in size to Earth's stellar black holes. Black holes formed after the explosion of massive stars are known as stellar black holes. The lightest one known weighs just over 3 solar masses, while the heaviest known weighs just over 60 solar masses. There are also intermediate mass and supermassive black holes. In September 2020, astronomers announced that they'd observed a record-breaking merger between two black holes. One was 66 times the mass of the Sun, and the other 85 times. The merger took place about 7 billion years ago and was detected because of the gravitational waves that it gave off and that have only just reached us here on Earth. Supermassive black holes lie at the centers of galaxies, including our own Milky Way. One of the largest known lies at the heart of a remote luminous galaxy called S50014+81. It's 40 billion times the mass of the Sun and has an event horizon beyond which you'd have to travel faster than light to escape. That's many times bigger than our solar system.